Good morning, my dear students. This is my first session for B.Sc 2 students. Now, today I am discussing about the polarization. This polarization chapter comes under wave optics. As you know that this year for the fourth sem, I am dealing with what? That is what? One particular unit. That is one chapter is based on the laser and another chapter is it is on the polarization. Here, polarization chapter comes under wave optics. Again, in the wave optics, you are studying the phenomena of interference, phenomena of diffraction, and phenomenon of polarization. I think probably Young sir might have discussed about the interference and all that. There, the interference theory was completely developed by the what Huygens wave theory of light, and also earlier there is Newton's theory of light. Here, according to Huygens, light is a longitudinal waves, and in order to travel the light also there is some particular medium is required. That medium is existing around us, that is called as what? Ether medium, that is. Later, there is Michelson, Morley and all that, they conduct the several experiments he conduct here. Then later they disproved that there is no existence of ether medium. And one more important point is, the phenomena of interference and the phenomena of diffraction, the Huygens considered completely that is light is electromagnetic waves, no doubt. But light is a what? It is a longitudinal waves, just like a sound waves or mechanical waves. But later, in the phenomena of polarization, what is the important outcoming of polarization is, the light waves are not longitudinal waves, they are the transverse waves. They are the what? Transverse waves and all that. What is transverse waves is, suppose the wave propagates like this. Each particle in the medium, it will vibrates in this direction, perpendicular to it. This is what the transverse wave. And also, we know that in the last semester, the light is consisting of what? Electrical field and magnetic field vector. Suppose electrical field is along x direction, magnetic field is along y direction, and the light will travels in a direction perpendicular to both x and y. It is electrical field vector, this is magnetic field vector, and perpendicular to it, then what happens? The light will be what? Propagates and all that. Okay, leave it all these things. What is the outcoming of polarization is, what the polarization concept tells us is, it teaches us the light is not a longitudinal waves, but they are the electromagnetic waves. Okay. Now let us come to the topic now, introduction of this topic. Here you see, this is called the unpolarized waves. I am using the word polarization repeatedly. What is polarization is, suppose the moment the teachers enters into the classroom here, all students you are facing towards the board only. That is what? Polarization. Or else, I will give you one example. Suppose some molecules are there. HCl molecule. This is H plus and Cl minus. Plus, minus. Plus, minus. Plus, minus, plus. Like that. Minus, plus. Like this, they are arranged. HCl molecule. One is hydrogen and another one is what? Chlorine. Here, in the absence of external electrical field, all molecules are arranged in the random direction they are arranged. It is as good as each HCl molecule is considered as a student. You can consider, imagine that it is a student. Now, when I subjected to the electrical field, I will apply the electrical field. I will apply it. This is plus and this is what? Minus. When such kind of electrical molecule, that is what? That is, it is electrical field. When HCl molecules, when they are subjected to the external electrical field, what happens? All molecules will be arranged in this fashion. You see, this is minus, plus, this is plus, minus, like this. Minus, plus, minus, plus. See, all are arranged like, because this plus molecule is attracted to the negative and this minus molecule is attracted by the what? Positive. See, all are arranged in the perfect orientation, perfect direction and all that. This is called as a what? Polarization. I have given the one more example also. In the absence of the teacher in the classroom, all students are oriented in different directions. One following in this direction, another following in this direction and all that. The moment the teacher entered into the classroom here, when you start for talking something, then your face is what? Towards the what? Board. That is called as a what? Polarization. But here you see, this is called as an unpolarized. This is called as an unpolarized because some vibrations are like this particle, that is electrical field vector, like this. Some vibrations are like this. Some vibrations are like this in this plane. Some vibrations are like this. This is called as an what? Unpolarized wave here. Unpolarized source of light. Come to this. Here also you see, one set of waves are propagating like this. They are vibrating in a direction that is what? Like this, perpendicular to the direction of the speed of the light. The wave is traveling in this direction. But one set of waves, electrical field vectors like this, and you see the dotted line represents that is the electrical vector. It is perpendicular to the plane of the board. Perpendicular to the plane of the board. This is important. Next future, I am using this diagram. This dot indicates it is perpendicular to the plane of the board. And this, the length of this vector, what it represents is, it is in the plane of the board here. So that it is also unpolarized wave. This is also unpolarized wave. This is both are unpolarized. Unpolarized. Even I can say that this is symmetric about it. Symmetric means, you see, about this point, situation is like this, and about this point, the situation is more like this. This is called as a symmetric. And you see, about this horizontal line, you see, about this horizontal line, the situation here and the situation here, they are what? Same here. It is as good as take an apple and then cut it. Then you are getting what? Two symmetric portions you are getting here. That is called as what? Set. Whenever the light vibrations are symmetric, then it is called as what? Unpolarized. This is also unpolarized because it is mixed with two components. One vibrations are like this. One vibration set of vibrations are what? Like this. Both are called as what? Unpolarized wave and all that. Now let us come to this. Here you see, this is consisting of vibrations are only in one plane. You see, the wave is propagating like this here, but the vibrations are like this in the plane of the propagation of the what? Light here. But here you see, the light is propagating like this, and the vibrations are confined to the perpendicular to the plane of the board. Both are having only one set of components. It is one set of components. It is as good as you can speak, that is in the classroom only the B.Sc two students are there. But during prayer, all the B.Sc 1 is there, B.Sc 2 is there, B.Sc 3, all students are what? Mixed. That is what? Unpolarized. It's not exact, right? So that these two are called as a polarized wave here. These two are called polarized. But don't forget to write this C. This C represents the direction of propagation of light. Next question is, how to obtain this kind of light, polarized light? I want to filter other components. I want to get the vibrations restricted to what? Only in one direction. That kind of light can be obtained by the different methods. One is by reflection. Refraction method I can obtain it. And double refraction I can obtain it. By scattering I can obtain it. And another one is what? Dichromatism. That is what? There are 4 or 5 methods are there. By that methods I can obtain the polarized light can be obtained. Now, is it clear? What is polarization? That is the phenomena in which the vibrations are confined. The phenomenon in which the vibrations are confined in only in one direction. Listen carefully. The phenomenon in which phenomenon in which the phenomenon in which vibrations are confined in only in one direction, only one direction is called polarization, students. This is the basic definition. Is it? What is the definition? The phenomenon in which vibrations confined what? Only in one. You see, the vibrations are this. Here there is vibrations in this plane. So that these are called as in what? Polarized. Or in other words, you can say that this is symmetric. This is what? Asymmetric. It creates a confusion. No problem. This is called as an unpolarized source. This is called as a polarized source of light. This polarization of light can be obtained by different methods I told you. One is by reflection, refraction, double refraction, selective absorption, and another one is what? By scattering and all that. Okay. Next one is properties. Now students, now there is a one experiment to demonstrate transverse nature of light. 1 minute. Now you see, it is one crystal. It is a tourmaline crystal, calcite crystal, quartz crystal, like that. It's a naturally occurring crystals. This is crystal A and this is crystal B. And this is what? Unpolarized light. What is unpolarized light? It consisting of vibrations in this plane, in this plane, in this plane, and what? In this plane. So there is a mixture of light is vibrating in all different planes. When this light is allowed to pass through this polarizer, you see, this is one crystal. Here, in the crystal, what happens is, the vibrations are in this plane. Now, it will be passes through it. It will be passes. Imagine like this. Only the vibrations in this plane are allowed to what? Passing through the crystal A, so that they are coming out. But it will cut off all the vibrations like this, and what? Like this. It will cut off that. Next is, I am holding another crystal B, that is, both are tourmaline crystal only. This is also like this. This is crystal A and this is what? Crystal B, that is. Now what happens is, whatever the vibrations are coming through the A in this plane, all are what? Passing through what? Crystal B. Because how they are? Both crystal A and B, how they are? Parallel, that is. Both crystals A and B are parallel. So that whatever the vibrations are coming out through the crystal A, all the vibrations, that is components, they are coming out through the crystal B. That's why this crystal B, I call it as a what? Analyzer. I am analyzing. I am observing through this crystal. That's why I call it as a what? Analyzer. This is the crystal A produces the polarization. It filters all the vibrations. It allows only one component of vibrations. That's why I call it as a what? Polarizer. Next is crystal B. I will rotate like this. But A I will not rotate. A is fixed. This is crystal A is fixed. This is crystal B. It is go on rotate like this. Just like this. When the crystal A is perpendicular to A, is how they are? Mutually what? Perpendicular. Initially how they are? Parallel, that is. Now crystal A is what? Fixed. This is A is fixed and B is gradually I will rotate it like this. Now what happens? There is no light is coming out through the crystal B because both are perpendicular, that is. It will cut off all the vibrations. Again, crystal B, it is go on rotate like this. Now you see, again becomes what? Parallelity. Then again rotate it like this. Again it becomes what? Perpendicular. So that again it will cut off the what? Light. Again I will rotate it like this. Now both are again, they are what? Parallel here. So that in one complete set of rotation, that is 2 times of maxima and 2 times of what? Minima you are observing. What is the intensity of the light? The 2 times it is what? Maxima, and another 2 times it is what? Minima. You see, crystal A and B both are parallel. Now what light you are observing? The maximum intensity you are observing. Now crystal B rotated like this. How they are rotated? 90 degree. What is the intensity of light here? 0, that is. Again crystal B is rotated. Again both are A and B, how they are? Parallel. Now again the intensity is what? Maximum. Again crystal B is what? Rotated. What is the intensity here? 0. Again I will rotate it here. Again that is intensity is what? Maximum. In one complete set of rotation, what happens is, that is intensity of this light coming out through the crystal B is 1 time, 2 times maxima and 2 times it is what? Minima. It is intensity. This is what? Theta. This is the what? This one, you see. We should touch this. Because at this point, intensity equal to what? 0. 0 degree, 90 degree, 180, 270, 360. It is what? One complete set of rotation. Of course, definitely the intensity of light should change here. Whatever the intensity is there here, that is the initial intensity, it is unpolarized light. Here, after coming through this crystal, I1 equal to I0 divided by what? 2. And since the crystal B, both how they are? Parallel. Here also, it is intensity I2 equal to what? I1 equal to I0 divided by what? 2. This is the intensity of light. Now, if this crystal B is rotates like this, what is the outcoming intensity equation is the intensity, the general formula I2 equal to I1 into what? Cos square theta. Cos component, how it comes and all that, don't worry, that is, I'll tell you later. Here, you see, both how they are? Parallel. When both are parallel, that is theta equal to what it is? Theta equal to 0. When theta equal to 0, you see, theta equal to 0 degree, cos 0 equal to what? 1. Then I2 equal to what? I1. Next, theta equal to what? 90 degree. Then cos of 90 equal to what? 0. Then I2 equal to what? 0. Next, theta equal to what? 180. Cos of 180 equal to what? Minus 1. Square it. It is what? Plus 1. Again, the intensity is what? Maximum. Like this, 270. That is, again, we substitute cos of 270 is what? 0. Intensity, it becomes what? 0. Anyway, the intensity of light coming through the crystal, this is the general equation. This is how it comes, and don't worry, that is. This I1 equal to what? I0 by 2. It is an average value, that is. What the mouse is what? Static. Why the intensity is reduced? Because it cut off all the vibrations, it cut off, that is. But it allows only the vibrations are parallel to the crystal, that is parallel to this plane of the crystal. It allows only this component, it allows. It will filters all other component, it filters here. That's why that average value I1 equal to what? I0 divided by 2. And this is the most general equation. I2 equal to I1 into what? Cos square theta. Here, how this is? Now, this is the intensity of the light. This is like here. Intensity is directly proportional to the square of the amplitude. This is what? Amplitude A0. Now, when the crystal A is B, it is rotated like this. Now it is rotated. When the crystal B is rotated like this. When it is rotated like this crystal B rotated so that this makes an angle like this. This is the angle what? Theta. I think you can able to understand. Both are like points. Now it is like this. Now this is in the in the rotated position. It is like this. Faraday's rotated position, you see, can I draw the line here? Now, this becomes like this. It will cut off this portion. Light will be what? Cut off here. Now, I will draw the perpendicular and all that. The component of this along this direction equal to what? I1, it is what? A equal to, this is A1 equal to A0 into what? Cos theta. A1 into what? Cos theta. This angle. Alternative angles are what? Equal here. This angle is 90 minus theta and all that. This becomes A1 equal to A0 into cos. What is A1? A1 is the amplitude. This is the amplitude. Actually, initial amplitude is how much it is? A0. But it will cut off what? This portion. Then intensity is directly proportional to square of the amplitude. So that I equal to, it is A0 square into what? Cos square theta. What is A0 square? Initial amplitude. It is like this, A0. And initially, the square it, this becomes what? I0. That's why I have written I equal to I0 into what? Cos square theta and all that. Of course, from the point of examination, it is not at all required. Just to remember, like, but I explained how it comes. Even in the books also they not explained how this component comes and all that. Here, from this experiment, what you learned is the light shows what? Transverse in nature. Light shows the what? Transverse in nature. Earlier, the people thought that light is a longitudinal waves and all that. Here, this diagram, that is in the notes also given here, like this. This is the light is what propagates. Now, these are the, this is unpolarized light here. This is unpolarized light. Now, this is the crystal A. Now, it allows only what? Vibrations like this. Now, the crystal B is rotated. And this crystal B is rotated. You see, it is making an angle of how much? 90 degree. You see, this is the axis. This is your original axis. This is like this. This crystal B is what? Like this. And how this is perpendicular. This is theta equal to what? 90 degree. So that I have not shown anything here. This intensity equal to what? 0. Here I1, this intensity. Here I will call it as what? I2 is the intensity. That everything I explained even in our notes and all that. From this, what is the conclusion is light, that is in this experiment demonstrate the transverse nature of light. What kind of crystals I am taking here? The tourmaline crystal. Here the tourmaline crystal 1A and another one is crystal B. That is. You might ask the question, sir, both A and B if are rotated like this, what happens? When both A and B are rotated here, then simultaneously again the intensity is also what? Changes here. Don't bother about this. And this is called as an analyzer and this is called as an what? Polarizer. Totally, I'm using the new word I'm using, that is called as plane of polarization. The light is what? Plane polarized light. I will call it as what? Plane polarized light. Okay. Now, next one is I'm going to explain what is plane of vibration and plane of polarization. Now, let us see. What is plane of vibration and plane of polarization? Normally it is 2-mark question. This is called as unpolarized source of light. Unpolarized source. You want to ask the question, which is unpolarized source? Light coming from the sun, light coming from the any bulb. It is an unpolarized source. This light is passing through the crystal. It is called as a tourmaline crystal. Tourmaline crystal. It is the name of the crystal. This is a dashed line I drawn. No, it is called as a axis of the crystal. This is called as axis of the crystal. It is as good as it is like this. Now here the light is there. This light vibrates in this direction, or sometimes it vibrates in this direction it vibrates. But as I told you, it allows only this plane of because it is parallel to this here, so that it allows only these vibrations are what allowed. The vibrations in this plane, this is called as a plane of vibration, that is called as a plane of vibration. That is, remember, what is plane of vibration? The plane in which the light vibrates is called as a what? Plane of vibration. It is represented by what? This one, A, B, C, D, represented by A, B, C, D is a plane. And this dotted line I drawn now, this is called as a plane of polarization. That is plane of polarization. This is called as plane of polarization. Plane of polarization. What is plane of polarization? A plane perpendicular to the plane of vibration is called as, this is one plane and this is what? Another plane, students. It is the vibrations. And assume that here there is one axis is passing through it. This is called the plane which is perpendicular to the plane of vibration is called as a plane of polarization. Listen carefully. What is plane of vibration? The waves will vibrate what? In this direction. Now it is what I am talking about, another plane. This plane is called as in what? Plane of polarization. Here two more questions. What is plane of vibration and what is plane of polarization? Remember, the plane in which vibrations occurs is called as the plane of vibration. The plane which is perpendicular to the plane of vibration is called as a plane of polarization. Now, the light can be polarized by different methods. I told you. What are the different methods? Is the light can be polarized. Light can be polarized by first method, reflection. This is the phenomenon. Second one, refraction. Third one, double refraction. Okay, double refraction. Next, fourth, selective absorption. That is selective absorption. Next, fifth is scattering. Here, don't bother about what is scattering and all that. You don't bother. Just you bother about double refraction. You bother, and another one is what? Reflection. That is for your syllabus and all that. Okay, that I will discuss one by one. The light polarization by what? Reflection. Or also sometimes it is called as a Brewster's law, or sometimes it is called as a Mole's law. Also they will call it as. Students, let us consider any one optical medium. What is optical medium? The medium in which light propagates is called as an optical medium. It may be water, it may be benzene, it may be glass, it may be any transparent material or semi-translucent material also. Here I have drawn one normal, I will draw it. This is the incident ray. This incident ray is consisting of what? Vibrations in a different plane. This is called as unpolarized light. This is called as an angle of incidence. I will call it as a what? Theta p. Why I am calling it as theta p, I will tell you later. This angle is called as theta. That means I equal to theta p. Polarizing angle, that you call it as. Okay, fine. Now, whenever the light is incident on any glass medium, water medium, always three phenomena will be take place: reflection, refraction, and absorption. But here, absorption is negligible here. I am not considering absorption here. This is the reflected light. And this is the what? Refracted light. This refracted light, it is what? Angle of refraction is what? R. R is called as a angle of refraction. Of course, this refracted light, still it has got all the components are there. Mixed components are there. Vibration in this plane, vibrations are in this plane and all. This is called as this point, I will call it as what? A, this is A, this is O, this is B, and this is what? C. What is AO? AO is called as incident ray. Incident ray. What is OB? OB is called as reflected ray. Don't confusion. Reflected. Then OC is called as refracted ray. As you know that in the laws of reflection, angle of incidence is equal to the angle of reflection. It is always angle of incidence is measured between the incident ray and what? Normal. This is incident ray and this is what? Normal. This angle is called as angle of incidence that you studied. This is the normal, this is reflected ray, and this is angle of reflection. How I have written here? This theta, angle of incidence, is equal to the angle of reflection according to the laws of reflection. That is. But you might ask a question, what about what kind of components are there? Still it has got mixed components, nothing is separated. Now what I will do is, as the mouse, what he said is, this incident is the angle of incidence, he will gradually change it. Gradually go on, change it. Either we can increase it or decrease it. Now if it is like this, it is 90 degree. Now go on, decrease it. Go on, decrease it. And it comes like this, angle of incidence equal to what? 0. Because it travels along the what? Normal. But here one particular angle, it may be 33 degree or 37 degree. That I don't know that is. For that, what happens? This consisting of only one set of vibrations are there. One set of vibrations. This dot represents how the vibrations are perpendicular to the plane of the board. Next, this set of consisting of what? Mixed one. That is mixed one. It is 100% that one. That is what. Some books they are shown only like this, but it is not like this. It is a mixed components are there. It is not polarized, but this is what? Polarized light. Here, the Brewster, he made one statement. This is possible. 100% of light is what? It is polarized light. Only one set of components are obtained. It is possible only when refractive index equal to tan of theta p. What is theta p? Theta p is called as polarizing angle. Polarizing angle. I think it is clear for you. That means go on, increase the angle of incidence or decrease it. Now what happens at one particular angle? What happens? All these vibrations are what? It is separated. You are getting only one set of what? Vibrations you are getting. This is called as a polarized light here. That's why. How you are getting? By the phenomena of what? Reflection here. Then he said that the Brewster, he made a statement that is what? For a particular given medium and also for a particular given color, that is refractive index is equal to the tan of the polarizing angle. And we know that n equal to sine of theta p divided by what? Cos theta p. This is equation 1. Next, According to Snell's law, we know that n equal to sin I divided by what? Sin I. What is I? Angle of incidence. This is theta p divided by sin of what? R. What is R? Angle of reflection. This is according to which law here? According to Snell's law. It is according to what? Brewster's law. This is according to Brewster's law, and this is according to what? Snell's law. Now I am comparing equation 1 and 2. LHS are same, then RHS should be what? Same. Now sin of theta p divided by cos of theta p equal to sin of theta p divided by sin of what? R. Now what happened? Which factor get cancels now? This factor is get cancels. What is left here? Cos of theta p equal to sin of what? R here. Cos theta p equal to sin of R. Next. Now, this one, can I write like this? Cos of theta p equal to sin of 90 minus of what? Can I write like this? Not this one. It is equal to cos of what? Because cos of 90 minus theta equal to what? Sin theta and all. Now, I will cancel this cos term. This cos term is what? Cancels here. Then what is left here? Left equal to theta p equal to theta p equal to 90 minus of r, or else theta p plus r equal to what? 90 degree. What is the conclusion from this? This angle plus this angle equal to what? 90 degree. You see, for the straight line, this complete angle equal to what? How much it is? From here to here, it is 180. From the geometry, definitely this angle plus this angle is equal to what? 90 degree. Whether it is clear or not, I don't know. Once again, I will explain here. This plus this. This plus this. Theta p, what is theta p? This angle. And this is what? R. These together, it is equal to what? 90 degree. Then certainly, this and this angle between the reflected ray and refracted ray is also what? 90 degree. That means, according to Brewster, when the light is completely polarized, Brewster's law, when light is polarized, 100% reflected ray, angle between reflected and refracted ray is 90 degree. This is the statement. It is very, very important. Sometimes we get the problems also here. If you want, I will explain it once again. What? Here, this is the what? One refracting medium. This is the what? Normal drawn it. This is the normal. This is the what? Angle of incidence. Incident ray. This angle of incidence, I will call it as a what? Theta p. And what kind of light is there here? It is an unpolarized. It is not polarized. It is in a what? Unpolarized light. When the light is incident on it, you are observing how many phenomena? One is reflection and another one is what? Refract. This is called as refracted ray. Refracted ray. This is called as a reflected ray. Reflected ray. According to laws of reflection, when this is angle of incidence, this is angle of reflection, it is also what? Theta. Angle of incidence is equal to the angle of what? Reflection. Now, this angle of incidence, you won't change it. Either can increase it or decrease it. At one particular angle of incidence, what happens? Only that is one set of vibrations you are getting. Only one set of vibrations. It is as good as B.Sc 1, B.Sc 2, B.Sc 3 3 students, all mixed here. I am separating only one set of components, whether one first year student or second year student or third year student. It is completely what? Polarized here. When this is polarized, and this angle is called as what? Sorry. This is called as angle of what? Refraction. He said that, but this is not polarized light, students. This is not polarized. It is containing the other vibrations, so it contains. Now this is what? 100% possible. He made the statement, this is possible when refractive index equal to what? N equal to tan of the what? Polarizing angle. Here, this is N equal to what? I can write sin theta p divided by what? Cos theta p. This is equation 1 I write. And also I know the Snell's law, I know that N equal to angle of incidence. Sin I by what? Sin I. Nothing but what it is? Theta p. Theta. Divided by what? Sin of what? R. This is equation number 2. You compare these two equations, you compare it. Sin theta p divided by cos theta p, because LHS is same, equal to sin theta p divided by what? Sin of what? This get cancels. What is left? Cos theta p equal to sin of what? Can I modify this? Cos theta p equal to cos of 90 minus of what? This angle, this cos get cancels. What is left? Theta p equal to 90 minus r, or else theta p plus r equal to what? 90 degree. From the geometry, you see, this angle plus this angle equal to what? 90 degree. Then certainly this angle equal to, that means angle between the reflected ray and refracted ray, it also what? 90 degree. This is what? Bristol's law. Remember, students, N is the refractive index. This value, N value, it depends upon polarizing angle. It varies from material to material and color to what? Color, that is. It is not same for all the colors. Suppose one glass is there. You are using either red light you are using or green light you are using, the blue light. Don't think that the theta p is same for all the colors. It varies with respect to color and also with respect to what? Medium, that is. This is what the polarization by what? Reflection. Normally, you are getting the question on this. Very problem is very simple. This is important. What is this important here? That is, whenever the light is 100% it is polarized, that is theta p plus r equal to what? 90 degree. This is important condition. When this is possible, then reflected ray and refracted ray are mutually what? Perpendicular. Okay, now I will stop the discussion in this video. I will just stop it. In next video, I will go to discuss the rest of the part. There is double refraction is there, Nicol prism is there, construction is there, analyzer is there. That I will discuss in the next video. Thank you.